We have seen in the previous class, t, the value of t is 52 minus 50 divided by 5.1 divided by root 50, that is 2 divided by 0.72, that is 2.78. We have to check with the table now. That will be our step 5. Okay. We have to just check from the table value, and this is known as a calculated value. So we have to table value and calculated value we have to check, right? So Z table. So we have to see the Z table. Now we find the critical value. The critical value for right-tailed test at alpha equal to 0.01 is Z alpha. That is, you can see the table and you can see that it is 2.33. Then the sixth step, we have to compare this value with our calculated value, right? What is our calculated value? It is 2.78. So we have to compare now. Now we have to take the decision. Now to take decision whether to reject or do not reject the null hypothesis. That is the decision we are going to take. Now to take the decision about the null hypothesis. Okay, we compare the calculated value of test statistic with the critical value. Critical value is nothing but our table value, right? Since the calculated value of test statistic, okay, what it is? 2.78, right? This is our calculated value is greater than the critical value. What is the critical value? This is from the table. Critical value we got from the table, that is 2.33, right? What is the value? From the table we got it as 2.33. That means the calculated value of the test statistics lies in the calculated value of test statistic lies in the rejection region. It's okay, at 1% level of significance. Okay, and 99% we are sure it is in the rejection region. So we have to take the decision now. The decision taken is, so we reject this is the decision we are supposed to take. We reject null hypothesis and support. When you reject, one should be other should be accepted. No, only these two together is a whole. Okay, one is complement of the other. If you reject one, that is, if one is false, the other should be true. Okay, we support the alternative hypothesis. So we support the alternative. So alternative hypothesis is our claim. So we support the claim. Thus we conclude. Now we go to the conclusion. Thus we conclude that this is our conclusion. Okay. Thus we conclude that sample does not provide us sufficient evidence against the claim, so we may assume that the average weight of potato has increased. Okay, this sum we have completed. We go to the next sum. Next sum is a sample survey indicates that out of this sum we have completed. A sample survey indicated that out of 332 birds, so these many birds, if you see, 1705 were boys and the rest were girls. Do these figures confirm the hypothesis that the sex ratio is 50:50? Test 5% level of significance, right? Ratio is asked, so it is population proportion. So here the question asked is population proportion. So we'll go back to we'll solve the sum. What is this? Example 2, I think, right? Example 1 we have already completed. We are going to the example 2, right? Example 2, what it says, we will first write it down, starting with the null hypothesis that the sex ratio is 50:50. Okay? Starting from the that the sex ratio is 50:50. So okay, we may write it is proportion, no? It's not average. So we have to write the proportion. H naught such that this is population proportion. Okay, population proportion is P of H naught. Okay, 50:50, no? That is half, right? And what is alternative hypothesis? It is not half, right? Alternative hypothesis is 50 is not equal to PH naught. That is not equal to half. Here we go for the two-tailed test, and the previous example we went for the one-tailed test. We don't know it is greater than or lesser than. So we are having the cross. What it is, greater than or lesser than, we cannot claim because we don't know about it. But one thing we can say that it is equal to half or not equal to half, right? So it may be greater than half or it may be lesser than half. So that will be our alternative hypothesis. So it is both the sides may be greater than, okay, it may be lesser than, right? It may be greater than side or it may be the lesser than side. So what we are going to, this is our critical value, okay, and same way we will be having the critical value in the left side also. So it is two-tailed test. Okay, so we have to see the Z table accordingly for the two-tailed test. Now we go back to the question. Hence the probability of boy birth is equal to probability of boy's birth or P, okay, which is equal to half, it is given, and the probability of girl birth will be 1 minus P of girl birth. Okay, we have talked about the boy's birth, no? Now we'll talk about the girl's birth, that is Q. Okay, girl birth is also Q equal to half, right? That is 1 minus P. 1 minus P is 1 minus half, that is equal to half, right? Consider the boy birth as sexes, okay? Okay, if you consider boy birth as a success, that is, we are taking P equal to half. Boy birth is a success, no? That is P equal to half. And Q birth is failure, that is 1 minus P, that is equal to half, right? And what is given about N? N in the given in the question is 3 2 3 2. This is given in the question. We saw, no? That question it is given. Now standard error of proportion. Okay, we have to calculate the standard error of proportion. Okay, of sexes. Always it is calculated for sexes only. So standard error of proportion of sexes will be, formula is PQ by N root of this. This is the standard error. What is my P? Half. What is Q? That is also half. N is 3 2 3 2. Okay, if you calculate the value we will get is 0.0088, right? Now observed sample proportion of sexes or sample proportion of sexes, which is equal to how many boys are there? 1705 boys. It is given in the question, divided by total number of births is 3232. That is, we'll get the answer is 0.05, nearly half, right? 275, right? And the test statistic. Okay, we have to use the formula for the test statistic. What is the formula? We have to calculate Z because it is more than 30. No, it's very much more than 30. 3232, 3232. This is more than 30. Using the law of large numbers, we have to see it as a table because all the distribution more than 30 follows the normal distribution, that is law of large number and central limit theorem. Using both we get, so we are taking the Z statistic, that is a P proportion of sexes minus a P that is given in the question, that is half, right? 50 girl and 50% girl and boy, right? That is we have taken half, right? So this is the what it is. So it is 0.5275. It is given in the question. Okay, now we have calculated, no? Sorry, I did mistake here. No, 0 is not here. Okay, it is 0.5275. Okay, minus it is 0.5 is a P, that is half we have taken, no? That is half is 0.5 divided by standard error we have already calculated, that is value 0.0088. We have calculated here, no? 0.0088. That is what we are using. So the answer is 3.125. This has to be calculated compared with the table value, that is the rejection region. It is greater than 1.96 because we have taken the 5%. Question given here is 5%. Okay, level. we have to remember, instead of seeing the table now, we can easily remember this, that is 1.96. So the calculated value is greater than the table value.